Hello, today we're going to continue our lesson on quadratic functions. First of all, let's just review some factoring. So when I'm looking at factoring, I need to find two numbers that multiply together to give me negative 10 and add together to give me negative 3. So I start out with just figuring out my factors of 10, 1 and 10, and 2 and 5. And I know because this is negative, they have to be opposite signs. And so I am looking at negative 5 and positive 2. And so if I factor this, I just write it x minus 5, x plus 2. All right. The bottom one, some of us have worked on splitting the middle process, so I will do that. If you are a guesser and checker, go for that as well. Remember, we do a times c, which is 3 times 2, which is 6. Write your factors of 6 down, which are 1 and 6, 2 and 3, and you need to get them so they're both the same sign, so they both have to be positive. Since this is plus 5, so it's got to be positive 3 and positive 2. You rewrite 3x squared, you rewrite plus 2, and then you write 5 as positive 3x plus 2x. Okay, so you can see that gives me 5. And then we factor by grouping. So I look at these two and take out a 3x. I'm left with x plus 1. Take out what's in common there, which is a 2. I'm left with x plus 1. Now I see that I have two terms that both have x plus 1 in them, so I pull that out front. And I am left with 3x plus 2. So hopefully this is just review for you, so you have factoring down. Then we have three forms that we talked about yesterday as well for our quadratics. The first one is standard form. Very helpful to find the y-intercept. Vertex form, which is helpful to find vertex, which is your HK. And intercept form, which is helpful when you need to find your zeros or your roots. All right, so yesterday you dealt with these questions. How does it open? What is the axis of symmetry? What is the vertex? What is the y-intercept? Today we are going to deal with the next questions. What are the x-intercepts? What is factored form? And where is the function positive or negative? All right, so if I'm looking for x-intercepts, that's the same thing as saying zeros or roots. So what I do is I factor it, and then I take each factor and set it equal to 0 and solve for x. Some of you may remember this from a benchmark in past. All right. Factored form. So what do I mean by factored form? Factored form means the same thing as if I have some constant out front and then x minus one of your roots and x minus your other roots. Very important that we know this terminology so you know what the question's asking. All right, so here's my example. I have x squared minus 4x minus 21. My first question is write it in factored form, so you're looking for two things that multiply together to give you negative 21, add together to give you negative 4. So I can write this as x minus 7, x plus 3. All right, so then if I want to find the intercepts, it's the same thing as saying solve x minus 7 times x plus 3 equals 0. So basically I'm taking each one of these factors, setting it equal to 0, and solving, and my answers are x equals 7 and x equals negative 3. Some of you may write them as an ordered pair so you know where it looks on the graph. So those are 2 points on our graph. Okay. now it says where is y positive? So if we're looking for where y is positive, it helps to think about where how the graph is opening. But it also can help you to do what we call a sign chart. So if you look at this graph, first of all, you can see that the a value is positive, and so it's a happy parabola, so it's going to open upward. We already know that this x-intercept is 7, and this x-intercept is -3. So you can tell by just kind of roughly sketching that your intercepts are there. And so you can tell from your graph where it's positive without having to do a sign chart. But I want to show you sign charts because I just kind of want you to get kind of familiar with them a little bit. So the idea is you can see it's going to be in the where I circled the black. So my answers are going to be from -infinity to -3 and from 7 to infinity. All right. Away from the graph, though, what you need to do is you need to break up the whole real line. So the whole real line goes from -infinity to +infinity. But you stop at each 0. So you go from -infinity to -3. And then you look at the next one, which is -3 to 7. And then you look at the next interval, which is going to be 7 to infinity. And now what I have to do is I just have to check by testing a value in each one of these intervals into my factored form and see if I get a positive number or a negative number. Again, we're just learning this, so just take our time with it. So I pick a number between there, say -10. If I put -10 in here, I end up with -17 and -7. And if I multiply two negatives together, I end up with a positive number. So I know that interval, my y is positive. If I pick a number between -3 and 7, say 0, and you put 0 in there, you have a -7 times a +3, and if you multiply those together, you get -21, which is a negative number, and therefore, if y is negative, it's clearly not positive, so that interval does not count as being y is greater than 0. Test another number, any number from 7 to infinity, so 10, 3 times 13. Don't really care what that actually equals. I just know it's positive. So again, you can see it's going to be positive in that region. Again, we can kind of see from the idea of it graphing. Now we should be a little bit better with our graph because another point we should grab on our graph is our y-intercept. And so from our y-intercept, we know that the y-intercept is always c. And so this point here is -21. All right, let's try another one. X squared minus 9. So first thing we do is factor it. So it's the difference of squares. So it's just x minus 3, x plus 3. And so if you want to find your intercepts, you set each one of these factors equal to 0, and you end up with +3 and -3. All right, and then let's do the sign chart before we actually think about what this looks graphically. So my sign chart, again, we're going to break up our whole real line. So we start at -infinity and go to our first 0, which is -3. Okay, then we're going to go from our 0 to our 0, so -3 to 3. And then we're going to go from 3 to infinity. Okay, now we just pick a number in this interval, say -10, and you put it back in to your factored form. So you have -13, -7, and if you multiply two negative numbers together, you end up with a positive number. All right, similarly, if you pick a number in here, say I'm going to pick the number 0. If I put 0 in here, I have -3 and a +3, and a negative times a positive will always give you a negative, so you know that is not where it is positive. And then 3 to infinity. So pick a big number in here. So say 10 or 100 or whatever number you want. But you'll see you end up with a positive and a positive because you'll have 7 and 13. And when you multiply together, you get a positive. So where is y greater than 0? Anywhere you got a positive number. Now, I guess I should be a little bit more accurate as far as on this one, there was an equals to. So we should really probably include our zeros. So I should put brackets on -3 and 7. Whereas this one is strictly only greater than, so I use parentheses. Okay, so how does that help me graph it? Well, if I'm looking at the idea that I know one of my intercepts is -3, the other intercept is +3. Again, I know the y-intercept is going to be right here, the c value, which is -9. Then I just go -9, and then I just draw my parabola, and I know that it's negative between -3 and +3, and then I know it's positive on the other sides of the 3's. And again, you know it should be a happy parabola because it has a positive a value, so it's smiling at us because it's positive. All right, let's try another one. All right, first thing we do is we factor this. If you've got the hang of it, please stop the video and try this one on your own. So I've got the idea that this is going to be factored, take out a -x, and so then I'm going to be left with x plus 4, right? We're just factoring out the common factor. And so this, when setting intercepts or finding intercepts, you set each factor equal to 0. So my answers are x equals 0 and x equals -4. So our points are 0, 0 and -4, 0. And then if I'm doing the sign chart, I start at -infinity, go to 0. Nope, sorry, go to -4. That's before 0. And then I go from -4 to 0. And I go from 0 to infinity. All right, and then we just test values. So pick a number in here. So if I do -10, I have -10. So that ends up being a positive. -10 plus 4 will end up being a negative. And so if you have a positive times a negative, you end up with a negative. All right. Pick a number between -4 and 0, say -2. Negative will end up being positive again. -2 plus 4 now ends up being a positive number, and so you have a positive number times a positive number, which is a positive number. And then if I pick a big number, -10 would be negative, 10 plus 4 would be positive, a negative times a positive ends up being negative. So where is this function greater than or equal to 0? Where it's positive, and again, because it's equals to, we now need to change these to brackets. So -4 included and 0 included. All right, so let's graph this. I know my y-intercept is going to be my c value, but if you look at the original, there is no c value. So therefore, my y-intercept is 0. I also know one of my zeros is 0, and my other 0 was -4. All right, and I know it's positive in -4 to 0, so I know it has to be positive here, and it has to be negative in these beyond. So if it's negative to start with, and then it's positive, and then it's negative, it's going to look like that parabola. And we should kind of think about that at the beginning of the problem because we see that it was -x squared. And if it happens to be -x squared, then we know that we have an unhappy parabola, and therefore it should face down.